the more basic part of what we're going to do today. Okay? So, you can plug it in. That might be risky. See if, yeah, maybe put it on that desk or something there. Because, I mean, you still need to plug it in there, but just don't leave it on the floor, is all I meant. Because that makes me worried. We'll get stepped on. If it'll reach to that over there. Yeah. I feel like it's a little less risky. Okay. All right, so, okay, so definitely one way that we could solve this is we could graph it. That is an option, right? So graphing would work for this. I'm not sure if it gives you a whole number answer or not, but it would work. But we are going to learn a new method today called substitution. And Aiden did this yesterday. So Aiden, what did you do yesterday to figure these out without having to graph them? Good. So both of them are equal to y, so that means they are equal to each other, right? So, like, for example, if we say that, you know, Anya is the same height as Lanaya, and Lanaya is the same height as Savannah, well, then it must be true that Savannah and Anya are also the same height, right? Because if they're all three equal height in this case, then if they're both equal to Lanaya, then they have to be equal to each other as well, right? So what you're doing here, we call this method substitution because you know y is equal to this stuff right here. So you can take y right here and mark it out and replace it with negative 4x equals negative 5x plus 5. And so now you have an equation that you can solve, right? So if we are solving this equation right here, Lexi, what would we do to solve this equation? We would add that 5x. And conveniently, that is 1x. So that's x equals, and then we have 5 left over here. So our x coordinate is 5. Now, a system of equations, the solution is a ordered pair. It needs an x and a y. Okay? So how are we going to find the y? What do you think, Isabella? It's easier than that. If I know an x coordinate, and I want to find the y coordinate that goes with it, what do I have to do? And just plug in 5 for x. In either equation, it doesn't matter which one you use. I usually just try to pick the one that looks the easiest. In this case, that's y equals negative 4x. So y would equal negative 4 times 5, which tells me y would equal negative 20. So my solution would be 5, negative 20. And that would be my answer. Now, I did not have to use that top equation. I could have used the second one. I could have done y equals negative 5 times 5 plus 5. That would give me negative 25 plus 5, which also equals negative 20. Right? So it does not matter which equation you pick. You can pick either one to plug back into. Okay, questions?
What if my equation is like x equals?
Good question. We're going to look at that. Such as what we see here, right? Now, the last problem, they were both equal to y. So they were both equal to the same thing, so they had to be equal to each other, right? That is not the case here. Any ideas on what we could do? What do you think, Eddie?
Solve for x.
We could solve both equations for x, or we could solve them both for y. We could do that. It's not going to be the easiest thing to do, though. I mean, it's not that difficult, but there's just an easier way. So the whole idea is called substitution, right? It says if y is, so like on this last one, y was equal to negative 4x. So I could take out the y in the second equation and replace it with negative 4x, right? So in this equation, I know x is equal to negative 9y, right? X is already solved for this value, right? Which means in the other equation, I could take this x right here, take it out, replace it with the negative 9y. Okay? It may be even helpful to you to do it this way. So if one of your equations is solved for a variable, so you have x equals or y equals, that's the one you want to plug into the other equation. So what I'm doing here is I'm going to write the x for right now, 2x plus 10y equals negative 32. I am taking the x out completely, only the x, not the 2 that goes in front of it, just the x. And I am replacing it with what x is equal to, which is this negative 9y. So I would put parentheses here, and I would have negative 9y. That. Now this is good because it now makes it where there's only one variable in that equation, so I can solve that equation. So let's see, Ian, what would I do to solve that equation? Good. So I have negative 18y plus 10y equals negative 32. What would come next? Very good. What's that going to give us? Negative 8y equals negative 32. And last step, divide by that negative 8. What do we get for our y, Ian? Good. Okay, so y is 4. But I need 2 coordinates, right? But let me stop for a second. Questions so far? Mm-hmm.
Is that an equation or a system?
It is what we call a system of equations. So a system of equations means that there are more than one equation. If you really want to get crazy, whenever you get beyond here, you could have like systems of equations that aren't just lines. You could have ones that have like 3 or 4. They could have 5 or 6 variables. Like it can get really complicated. You won't have to do anything quite that advanced in high school, unless you're majoring in something related. Probably not ever. But they can get really advanced. We will only see ones where we have like 2 lines that we're looking at here. So, okay, so we got y equals 4. We need to find the x that goes with it. We can plug it back into either one of these equations, but which one looks easiest? The x equals negative 9y, right? So if we just do x equals negative 9 times 4, we will get the x equals negative 36. So our solution is negative 36, 4. And you can see both of these we've done so far would be difficult to graph because their intersections are really big, right? We've got numbers that are really big. Now, if you see something like this on the final exam, which is on the real final, the EOG, if it is on calculator active, watch this. This is what's great about Desmos. If it's on calculator active and you can use Desmos, if I, 2x plus 10y, 2x plus 10y equals negative 32, and then my other one is x equals negative 9y, can graph them. I can't really see where they cross here, but if I zoom out, I can eventually see where they cross. If I click right here, there's a gray dot where they cross, negative 36.4. Right. So if you see this on Calculator Active, graphing is the easiest way to do it if you've got Desmos, because it'll do it really quickly. But a lot of what we're going to see is not going to be on the Calculator Active part. Okay, questions? All right, here's another one. It's similar to the last one. I'm going to let you try this one on your own. So where that y is at, we're replacing it with our negative 6x. That will give us a 42x. We'll combine. We should get 1 for our x there. And then you'll plug 1 back into either equation. The top one is the easiest. And we get negative 6. All right, questions? Mm-hmm.
Are there going to be like problems where both of them, or both of the equations, or is some going to be like the bottom one?
Possible, yes. Although we are going to learn another method that is going to be easier to use in those cases, but you don't know that yet. So yes, it's possible that neither one of them will be solved for a variable. All right, let's look at 4. All right. So, this almost looks like that's the case. Are either one of my equations solved for a variable? It almost looks like they're not. But there is one that is. The bottom one is actually solved for x. It looks like it's not because it's written backwards. But that x is over here by itself, right? So this one is solved for x. We would have noticed it a little better if they had written it like this. X equals negative y plus 3. It would like stick out to you more if the x came first. But x is equal to negative y plus 3. So this one's going to be a little bit different than the last problem because when we plug it in, what we're plugging in is a little bit longer. But we're just going to take this stuff right here that's equal to x, and we'll plug it in for our x, and make sure you put parentheses around it when you do that. So it will look like this. 6 times negative y plus 3. Got to have the parentheses around that. Minus 2y equals 26. Okay. Kama, what would we do to solve that? Good. So that will give us negative 6y plus 18 minus 2y equals 26. What would we do after that? Good. And that's going to give us negative 8y plus 18 equals 26. Keep going. What do we do next? Very, very good. We get negative 8y equals positive 8. And last step. Good. And what do we get for our y? Perfect. Okay, that gives us our y coordinate. We need an x and a y, so we could plug it into either equation, but the bottom is going to be a little bit easier. So if I do, now be careful right here. When you plug this in, negative y plus 3 equals x, you are erasing the y and the y only. That negative in front of it stays. And you're plugging in your value, which is a negative 1. So negative 1 is actually positive 1 plus 3 equals x. So 4 is your x. So we've got 4, negative 1 is our answer. Okay, questions? All right, we got one more that we're going to do. Yep, try it on your own. Plugging in your negative 3y plus 1, you should get negative 2 for your y. And then when you plug that back in, you should get a 7. So negative 2, 7.
Should it be the other way around, like 7, negative 2, negative 7?
Oh, it should. Thank you. I've got my points backwards. Let's fix that. 7, negative 2. That looks better. All right, questions?